So on this course, if you have the packet tracer, you can download it from here, from students resources. Then on the home page, you're going to see pretesters where you can just test your networking skills before you go ahead with the content. Then I've already unlocked the quiz on module 1 to 4. Okay, that's this module 1 to 4 exam. So you can actually take them after we've concluded module 1 to 4. Alright, then straight up to this. There are videos inside it, so you can go through them. Alright, let's just move straight to what we have, the slide on our slides. So after some slides, we'll just go straight to do some labs on Cisco Packet Tracer, which is very much important. And I was thinking maybe everybody will get to read the slides so we don't dwell too much on the slides and we'll focus more on the labs instead during the live classes.
Okay.
All right. So we have communications in a world of in a connected world, and looking at all these. Let's go straight to the content. All right, so we're looking at network types, data transmission, bandwidth, and throughput, client and servers, network components. So everything actually is on the network as long as you're connected to something, you're on a network. As long as you can send and receive information from something, you're on a network. So that's one thing that many people need to be conscious of, right? So um, people do not necessarily understand what internet is. They actually think is just being able to browse on the internet, okay? But rather, internet is actually once we're all connected together. Once you're connected to someone that is even beyond your region, okay? Once you're able to access files, you are connected to the internet. So who wants the internet? So basically, nobody wants the internet. So internet is just a connection of people globally. Let's look at local networks. So we have small home network and small office home office network. All right. For the small office home office network, allows computers within your home or remote office to connect to a corporate network and access centralized shared resources. So those people that work remotely, they can actually connect to their office remotely. So and that can be regarded as a small office home office network. So for local networks, we have medium to large networks, okay, and those ones can be those that can be found in schools, offices, hospitals, and the rest. Then the internet on its own is a connection of all these offices. I would say all these offices together. That's you can call that the internet. Okay, there's a video for you to watch. So look at mobile devices. These are devices that help to connect to the internet. We have your smartphone, we have your tablets, smartwatches, your augmented reality glasses, okay, and so many more things that can connect to the internet or that can be used to send files. So then in our home, we have our smart IP camera or webcam. All right. You also have your household facilities. The only thing is that in Nigeria, most of these things, some people do not necessarily use these IoT devices because these are IoT devices, smart refrigerator, the smart washing machine, and every other smart TV. Although smart TV is becoming more popular now, and very soon, given Nigeria in the next 5 years, we should have already exhausted our Internet Protocol version 4 addresses because of the increase in the usage of smart devices or IoT devices. So we also have our smart TV, our console, uh, also our stereos in vehicles. Then we have the RFIDs, which is radio frequency identifier tags, right? That can be placed on objects. It could be your car, it could be your device, it could be your vehicle, all right? That can help track devices. All right, so there are several other devices that can connect to the network, aside those that ranges from the ones that are being used in agriculture and those in hospitals. So let's look at data transmission. So the types of data that we have, types of personal data rather, are volunteer data, okay, and it's actually created and explicitly shared by individuals uh, on social networks, right? And it might include video files, picture, text, or audio files. Then we have observed data. These ones are the ones that are recorded, right? That are recorded by individuals or by companies or people that go out to observe. All right. They could also be captured maybe during phone calls. All right. They can be captured from applications also. Those are observed data, data that you just infuse. Then inferred data, all right, such as credit score, which is based on an analysis of volunteered or observed data. So inferred data is data that is actually gotten from data that have been gathered. Okay, for example, when data analysis is done to actually predict when people would buy ice cream more, right? So that outcome of the data analysis, the new data that has been um, captured, or the new data that is the result, is actually inferred data. So data has been transmitted in bits, all right, and we know bits to be zeros and ones, which is binary. All right, so bit is binary digits, and it represents what the smallest unit of data or the smallest piece of data. So in programming, okay, there's something called the American Standard Code of Information Interchange, which is ASC2. All right. So in this ASC2, every character, right, has its bit-wise code. All right. For example, capital A is different from small letter a, right? Capital letter A is denoted in this, and small letter a will be something else. All right. In Python, there's something called character and ordinance. So all character and ordinance, they all have different. All letters have different ordinances, both when they are in uppercase and when they are in lowercase form. The special characters also have their own also. All right. So common methods of data transmission. Data can be transferred through electrical signals, optical signals, wireless signals. All right. So optical signals can be regarded as light, through light transmission. Okay, using fiber optics cables. Or electrical signal can be traveled through copper wire, just like uh, coaxial cables, right? Ethernet cables, then wirelessly when data has been transferred over the radio wave frequencies. So let's look at bandwidth and throughput. Okay, bandwidth is actually the capacity of a medium to carry data. All right, so we have different bandwidths. For example, a 5G has a different bandwidth from 3G, 4G has a different bandwidth from 2G, and the rest. So the bandwidth now will enable you. Let me do something, let me break it down so that it's much more relatable. Now, if our bandwidth is about 10 Mbps, it means that only 10 megabits per second, right, can be transferred at once. Okay, so if we are two people using a Wi-Fi that has been assigned a bandwidth of 10 Mbps, that 10 Mbps is going to split and divide for both of us to use. So which means we cannot browse at a speed that is also 10 Mbps at a time, except one person is not using the internet to do anything. So nonetheless, this person can never browse at a speed of 10 Mbps. So now there's something called throughput. All right. So throughput is actually the amount of data that can pass through a media over a given time. All right. So there's something called the von Neumann bottleneck principle in data transmission. Uh, that he was explaining how a if you wanted to put seeds, probably stones inside a bottle, right? You have to put them one after the other. You do not put two at the same time, right? So that was what he was explaining. So there, it was when bandwidth, we now discovered bandwidth that um, that bottleneck was removed. Okay, so we're now able to what, transfer files, multiple files at the same time. So due to a number of factors, throughput does not usually match the specified bandwidth. And the reason why is because the amount of data being sent and received over the connection can vary, all right? And the type of data that is being transmitted to, and also latency created by the number of network devices encountered between sources and destination. So latency is actually more like delays, all right? The time that it takes from a data for data to reach, to go from a source towards destination. So the duration of data traveling from one point to another can be referred to as latency. That's why sometimes when you go to something like um, fast.com and you check your speed, do a speed test on your network, you see latency there. So what is a client? What is a server? So clients are actually normal computers, all right, like your laptop or your phone, right, that enables you to what, request information from a server, all right. Then client is a host, all right. Server is also a host, and they are both end devices. Now, servers actually are the ones that give information to clients. Okay, so server here it says that servers are hosts that have software installed which enable them to provide information like email or web pages to other hosts on the network. So there are different kinds of servers. There are email servers, there are web servers, there are file servers. So email servers help to run the email transfer protocol, all right, where clients use email client software such as Outlook and the rest to transfer information from their own email address to another person's email address. The web server is just what enables us to browse the internet by visiting different websites. All right. So when you enter www.google.com, all right. So Google's web server receives your request and sends you a reply. That's why your web pages show. So then file server actually stores files. in a central location, right? Just like something like we have your Windows Explorer now. Windows Explorer can act as a file server when it's on a network. Okay, we have different cloud um, platforms, right? Like Google Drive. Those are file servers because you can actually request files from those platforms. So, the for networks now, there's something called a peer-to-peer network. All right. So it says that some in small businesses and homes, many computers function as the servers and clients on the network. So this type of network is called what? Peer-to-peer. So when you just connect one laptop to another laptop, that's a peer-to-peer connection. Right? When you connect one desktop to another desktop, it's a peer-to-peer connection. And the advantage is that it's easy to set up, right? Less complex than other network, low cost, right, and can be used for simple tasks. Then disadvantage is that there's no central administration and it's not as secure as other network and it's not scalable. All devices may act as both client and servers, which can slow their performance. All right, so we have peer-to-peer applications, all right, that allows devices to act as both client and servers. So, example is like WhatsApp. So WhatsApp is a peer-to-peer application. All right. So you can see in this model now, every client is a server and every server is a client. So the P2P application requires that each end device provide a user interface and run a background service. In the figure, both clients can simultaneously send and receive messages. So just like we have with WhatsApp. All right. So a computer with server software can provide services simultaneously to as many clients that are connected to it. So a single computer can run multiple types of server softwares in a home or small business, and it may be necessary for one computer to act as a file server, a web server, and an email server. So and this when you hear a server is just basically another system, right? Or probably a high-end system, okay, that has a larger memory, larger storage, and a higher processor. So that's why it's able to what, send multiple files at the same time, offer different services. For example, your email, the email service, web service, and file transfer protocol service. Then let's look at network components. Okay, the in networking we have three categories. We have the end devices, we have intermediary devices, and we have the network media. So I explained before, a server or a host is an end device, right? An end device can be your phone, your laptop, your printer, anything at all that can be used to send or receive information is an end device. The intermediary device is something that can be used to send information from a source to a destination that helps or aids the transmission of information from a source to a destination. We have our wireless router, we have your firewall appliance, router, hub, switch, and the rest. The network media is actually a medium whereby the data is going to pass. And it could be wireless, which is air, it could be copper, it could be what? Optic fiber, right? Those are the three common network medias that we have. So you can see in this illustration here that we have different LANs. Here we have system, someone using laptop here. Those are different uh, end devices that are connected to an intermediary device. Okay, so this, for example, could be a switch, and these are routers, all right, that are connected to each other, and this is another switch. So what the router does that is select the best path for your request to pass and get to the what destination. So here it says that devices from the interface between users and the underlying communication network. Some These devices form the interface between users and the online communication network. Some examples of any devices could be computer network, telephone printers, I already explained all those things. We're going to do a lab in our next class. Next class, we're going to focus on a lab. So communications is a connected world. I've already explained a lot. Right? I explained how and what small network is, peer-to-peer, different end devices, what and what can be connected on a network. And let's move to the next module.
Okay, I'm with you. I'm still with you.
All right. All right. So module two talks about, let me change what I'm displaying. Online connections. So we're going to look at the wireless network, local network connection, um, network documentation. So modern telephones. It says, do you know that most phones can be connected to many different types of networks simultaneously? So mobile phone use radio waves to transmit voice signals to antenna mounted on towers located in specific geographical areas. Mobile phones are often referred to as cell phones because the geographic area in which an individual tower can provide a signal to a phone is called a cell. When a telephone call is made, the voice signal is relayed from one tower to another tower until it is delivered to its destination. It is also used to send text messages directly from the phone. And on the cell phone network, all right, we have 3G, 4G, 4G LTE, and 5G. And they are used to describe enhanced cell phone networks that are optimized for the fast transmission of data. So the G in these destinations represents the world generation. So three is generation. So 5G is the fifth generation of the cell network. So, and it shows here that the 4G will continue to be the dominant source of global mobile traffic in 2022. However, 5G will use an increasingly larger portion. So you can see in 2022, what was majorly used was what? 4G. And then you can see 3G dropped and 2G. 2G is just simply our edge connection. So we have other wireless things on wireless network that can be used to access the wireless network. We have the GPS, right? That is geographic positioning satellite. So GPS is a satellite, and to transmit signals that cover the globe, the smartphone can receive these signals and calculate the phone's location to an accuracy of within 5 10 meters. And Wi-Fi, which is wireless fidelity, transfers and receives trans- transmitters and receivers located within the smartphone let the phone connect to local network on the internet. So to receive and send data on the Wi-Fi network, the phone needs to be within the range of the signal from wireless network access point. So that range there is could be called an hotspot or a hotspot rather. Then we also have Bluetooth. We also have NFC, which is near field communication. NFC is mostly used in our Like for example, some smart cards or ATM cards have NFC ability, so you don't necessarily need to slide in your card somewhere. You just touch it on an NFC reader and you make your payments. So Bluetooth is wireless technology that allows device to communicate very short distance, and Bluetooth can be used to transmit both data and voice. It can be used to create small local networks, and NFC communication technology enables data to be exchanged by devices that are in very close proximity to each other. That's where you might need to take the card very close, usu- usually less than a few centimeters. So let's look at local network connections. So we have the LAN components. So to make up what makes up the LAN, which is local area network, is the host, the peripherals, right? The network devices and network media. So peripherals could be your cameras or scanners, right? And locally attached printers. Network devices, okay, are your halls, your switches, your router. Network media, it could be your network cable, which are copper cables, or the fiber optics. I've already explained what the hosts are before, which are your phones or your laptop. Then in your PC, all right, there's a place to you can go and adjust or impute your IP address, correct your IP address, okay? So the IP address actually identifies the host on the network. Subnet mask used to identify the network on which the host is connected, and the default gateway identifies the networking device that the host uses to access the internet or other remote network. So when you have a Wi-Fi connected to your MTN, when you're connected to MTN Wi-Fi or Glo router, MTN Wi-Fi or Glo router or any wireless device at all, and you enter in the default gateway in your browser, definitely it might just open up a platform where you can um, customize or edit the settings of that particular router or Wi-Fi, which is showing you how that Wi-Fi is connected to other networks, which is giving you access to the internet. So there's manual configuration and there's automatic addressing in networking. So the automatic is called dynamic IP configuration and the manual is called static, right? So a manual configuration, it requires you to enter the values by yourself. This is values of the IP address and um, or the network. All right. So most end user devices can be set up to receive network configuration information dynamically. For example, your laptop, you don't need to go and set up your IP address um, before you go and you're able to access the internet, because once you're not given an IP address, you might not be able to connect or connect to the internet or receive or send files over that network. So you must have an IP address. An IP address is always unique. Okay, you cannot have more than one IP address. So let's look at network documentation. The use of logical device naming and address conventions that are well documented can greatly simplify the task of training and network management and can help as well with troubleshooting when problem arises. So for example, now this is a network topology of a probably an office. Okay, you can see room one, room two, room three, room 201. This is probably on the floor. This is second floor. You can see 201. So the two there signifies second, right? And one row one in second floor, another. So this you can when um drawing up a network, okay, as a network administrator or network engineer, all right, you might be required to draw some topologies, all right, logical topology, physical topology. So this here is an example of physical topology that shows every system inside every room physically. You can see it's not showing anything that has to do with their IP address, the VLAN, virtual LAN that they are connected to, whether they're in the internet or the extranet, all those things. So that's because it's just a physical topology. So network topologies represent, uh, look at now, the physical topology shows where the wiring is installed and locations of the network devices that are connected to, that connect the host. So these diagrams use symbols or icons to represent the different devices and connections that make up the network. So the logical network information now, this is the logical topology. You can see, uh, let me use my laser pointer. So this is a logical topology here, where we have the, you can see the web server, email server, file server with all their different IP address, and look at the different IP address that this group uses to access the web server. The first one is for the web server, the second one email server, and the last one file server. So this is logical topology. It shows in details, but physical topology just shows the devices, right, and nothing more. But logical topology shows both the devices and their IP addresses, shows you the network they are connected to and how they're able to access different um, devices on the network. All right, so that's going to be the end of module 2. So let's move to module 3 now. So module 3 says explore network with packet tracer. So module 3 is basically uh, supposed to be lab oriented module. Okay, so let me share my screen. All right. So module 3 now. Module 3 says explore network with packet tracer. So we're looking at packet tracer, network simulator, packet tracer installation, basically everything that we need to do to be able to install packet tracer. So I'm going to drop a link on the group. Okay, I already showed it in the beginning of the class where you can download packet tracer from. So this is how packet tracer looks like, and where you can locate different devices, end devices, network devices, end devices, connections, which is going to be the media and the rest. So Safari Tracer simulates networks and network traffic. The physical aspect of this network also needs to be simulated. Okay, so I'll share it to you. Let me see if I can get back to that page. Where I accessed it. It's just under your student resources. So once you're able to, okay, so I'm going to paste it. Let me just paste it here. but it will require you to log in. It will require you to log in before you can download. All right, so
I can get it from the Cisco portal, Abi.
exactly, that's the only place you can get it. You can't
Okay.
download it outside the Cisco portal.
Okay. Okay, that's fine.
So finding a device to deploy requires looking in the device type section box. Okay, so the top row of icons represents the category of the category list consists of networking devices, end devices, components, connections, miscellaneous, and multi-user. So we're just going to be doing different labs in this, and I'm going to show you the GUI, the CLI when it comes to different devices. All right, so package research shows you the physical interface, how the device looks like physically. Okay, you can see here, this is an example of a network interface. All right, this is wireless network interface. Then it has a config tab for configuration tab. For example, your router, you can configure routers, packet tracer, and so on. So for some of the end devices, packet tracer provides a desktop interface as well. So for example, your phone, the PC, you're going to see how to open the desktop, right? So that's going to be the end of that particular module. So going to move straight to module 4. So module 4 is still another lab. Okay, module 4 is still another lab that we're going to be doing. It says what? Build a it says build a simple network. Let me quickly change what I'm presenting. So this you see Ethernet cable, coaxial and fiber optic cabling, twisted pair operations, verifying your connection. All right. So there are different media types. Look at, we have metal wires within cable. So data is encoded into electrical impulses, and we have glass or plastic fibers within cable for fiber optics, right? And we have wireless transmission. So this one, data is encoded via uh, modulation of specific frequencies of electromagnetic waves, all right, which is radio waves, microwaves, and the rest. Those radio waves, microwaves, they have specific frequencies that enables them not to interfere with each other. So common network cables, we have the twisted pair, which is very common. We have coaxial cable. This is how coaxial cable looks like. We have fiber optic cables. So Ethernet technology generally uses twisted pair cables in interconnected devices, and there are two types of connections when it comes to Ethernet cables. There is straight copper straight through and copper crossover, but the coaxial is one of the earliest, right, uh, for of networking cabling, of network cabling, right, and it uses a high frequency transmission line to carry high frequencies or broadband signals. The fiber optic is actually the latest, right, and it is the fastest, and it can either be glass or plastic, that and it can carry digital information at very high speed over long distances. So for coaxial cable on twisted pair cables, you might need to use something like a bridge, okay, to be able to extend the network. So for Ethernet
What is the
cables,
limitation of? Sorry, what is it? Okay, sorry.
we'll look at it. So the network in most homes and schools are wired with twisted pair cables, right? And it is actually reliable and it's always readily available. For example, in fact, these twisted pair cables, like I said, I came here today. I mean, I am where I am today because I just cramp some cables for this large LED screen. It's actually use twisted pair cables. So I have to use copper straight through to connect the two. So then this one now has your second response where you now use headphones
Okay.
and all that. So they are generally called signal and there are different
Okay.
levels. Let's say as you go on, you see the different frequencies because they have different speed. There's Cat 5, there's Cat 6, right? There's Cat 7. So there are different levels. They have different grades because these different grades they have different capacity, bandwidth, and speed at which they can transfer data. So Twisted pair uses pulse of electricity to transmit data, and data transmission over copper cable is sensitive to electromagnetic interference. All right. So when there's EMI, high EMI around it, it might alter the transfer of data. So another source of interference called crosstalk occurs when cables are bundled together for long lengths. All right. So those are, they transmit electromagnetic electric signal. So when they are close together, so there's like they are in the same electric field. All right. So because of that, that can cause what something called crosstalk. So interference can cause problems with data being transmitted on the cable. And look at the first one says what a pure digital signal is transmitted. You can see it's just in one pulse. So that's why it says transferred in what pulses. All right, 1 1 1 1 0 0 0 1 0 1 0 1. Right. Then for the second number two now, on the medium there is an interference in signal. All right, so there's interference. That's why it's showing this kind of wave. All right, this kind of electric wave. Then we have number three says the digital signal is corrupted by the interference with signal. So in this one, the data would be transmitted, but the data will be corrupted. Then the last one says the receiving computer reads a change signal. Notice that a 0 bit is now interpreted as 1 bit. All right, so you can see on the point. Let me look for where that is. Normally, when it's on one, okay, it's supposed to be up. When it's on zero, it's supposed to be down, right? So we have 0 0 here, and look at this one here that's supposed to be down, so it still went up. So let's look at the types of twisted pair cables. We have unshielded twisted pair and shielded twisted pair cable. So this is unshielded. Unshielded is very common, right? And these are the shielded. You can see there's some kind of white shield around it, and they are usually used in what European countries. So the unshielded twisted pair cables are used to connect workstations, hosts, and network devices. So Ethernet unshielded uh, twisted pair cables consist of 4 pairs of twisted pair cables. So same with the shielded. So these shielded now, they are immune to electromagnetic interference and radio frequency interference. All right. And these shielded twisted pair cables are expensive, not as flexible, and have additional requirements because of the shielding. So right here, you can see the different cables and their features and their speed. So you can see the Cat3 unshielded twisted pair. It transmits what at a speed of 10 Mbps per second, 10 Bps, right, and has a frequency of 16 megahertz. Cat 5, 100 Mbps, so you can get to 100 Mbps. Cat 5e, 1000 Mbps, and moves at a speed of 100 megahertz. Cat 6, 1000 Mbps, and the speed is what? 250 megahertz. Cat 6a, still 1000 Mbps, but has a higher frequency. And Cat 7 can transfer to what? 10 gigabits per second. So let's look at the coaxial and fiber optics. So coaxial cable carries data in form of electrical signals, and it provides improved shielding compared to the unshielded twisted pair, and can therefore carry more data. So it is used by cable television companies to provide service and for connecting the various components that make up the satellite communication system. For example, your DSTV, for it to connect to its dish, it uses what? This coaxial cable. All right. So this coaxial cable can even work with your AV wire. So you can use coaxial cable in place of your AV wire. We've done that a lot. I've done that a lot, usually for all these church programs when there's no long AV. We'll just use coaxial cable and join it to the AV head and just connect things like that, and everything will work normally. That was then when it was AV and we were not used to having HDMIs or SDI cables. So with the addition of a cable modem, the cable television provider can offer data and internet service as well as television signals and telephone over the same coaxial cable to customers. Like I explained, your DSTV. So that DSTV is like the cable modem. So usually it's usually terminated with a BNC or F series connector, and the outer jacket is an insulator to protect against electromagnetic interference and radio frequency interference. So a single center conductor is copper or aluminum. So um, this ion here could either be copper or aluminum. So it also have these metallic braids here that helps to shield against the words EMI and RFI. So for the fiber optic cables now, so fiber optics uses transmit data through light, okay, through pulses of light. So it is constructed of either glass or plastic, and it is immune to electromagnetic interference and radio frequency interference. So part of, we have the jacket, the strengthening material, the buffer, and the cladding and the core. So this cladding now is made from slightly different chemicals than those used to create the core. It intends to act like a mirror, right? And the core now, the light transmission element at the center of the optic fiber. So light pulses travels through the fiber optic core. So we can see the different parts here. The jacket, this is the strengthening material, the buffer, the cladding, and the core, which is either glass or plastic. You can see it's transparent. So the strengthening material surrounds the buffer and it prevents the fiber from being able to stretch, from being stretched when it is being pulled, right? And the jacket is typically a PVC jacket that protects the fiber against abrasion, moisture, and other contaminants. So let's look at twisted pair operation. So remember I said there is copper crossover, copper cross straight through. All right, so the color coding for the wire pairs in unshaded twisted pair cable is determined by the type of standard that is used to make the cable. So different standards have different purposes and are closely governed by the standard organizations. So there are two standards that are widely implemented for the Ethernet installations. TIE, EIA organizations defines two different patterns, which is called the T568A and T568B. Okay, so each wiring scheme defines the pinout or order of wire connections and the end of the cable. So one of the two wiring schemes should be chosen for a network installation. So you don't use two different wiring schemes. How do you know the difference? You see that you can see this one. We have green and white, green, orange and white, then blue and white, blue, then blue and white, orange, brown and white, and brown. So, but in this part now, this T568B, we have orange and white first, then followed by orange. We have green and white, followed by blue, blue and white, green, brown and white, and brown. So both of them, brown and white and brown, are always the same place. But what changes is majorly the what green and the orange. So twisted pair transmit and receive parts. All right, let's look at it. So the Ethernet network interface, the network interface card and the ports on networking devices are designed to send data over on shielded twisted pair cables. So specific pins on the connectors are associated with a transmitting function and a receiving function, a receive function. The interface on each device are designed to transmit and receive data on designated wires within the cables. So when two unlike devices are directly connected using the untwisted pair Ethernet cable, it's important that the transmit function and the receive function on each end of the cable are reversed. Take notes. It says that what it's important that when you are connecting what two unlike device, all right, say it is important that the transmission function and the receive function on each end of the cable are was reversed. So this cable is called straight through, the straight through cable, and it has the same color pattern on both ends. So whatever you have here is the same thing that you're going to have here, and it's called, that's the T5 68E. So let's look at verifying connectivity. So to verify connectivity, we just use the ping. Remember, during the other labs, we were doing ping this IP address, ping IP address. So the ping is actually what a host used to send, used to verify connectivity. You just send a request and expect a reply and notifies you that there's a reply. So a host sends message across the internet must have an IP address to identify it to the other device on the network. So the ping utility can be used to test end-to-end connectivity between the IP address of the sending host and the IP address of the destination host. So it measures the time that it takes test the message to make a round trip from the what source to the destination. All right, and however, if the test message does not reach destination, or if delays are encountered along the way, ping cannot determine where the problem is located. So the format of the ping command is ping, they put the IP address xxx 190.168.63.1, where this is what the IP address or domain name of the destination or host. So for example, this is an example here. We have ping 190.168.30.1 or ping www.cisco.com. So this is either you ping what the IP address or you ping what the domain name. All right, so the traceroute command, right, it is a utility that traces the route a message takes from its source to the destination. So each individual network through which the message travels is referred to as a hop. So when message moves from here to here, let's say message is coming from here to here. So this is like hop, first hop, hop two, second hop. So the traceroute command displays each hop along the way and the time it takes for the message to get to that network and back. So if a problem occurs, the output of the traceroute utility can help determine where the message was lost or delayed. So it tells you the hop that the signal was lost. So this traceroute now is called traceroute in the Windows environment. So on Linux, we might type traceroute. In Windows, we type what? Traceroute. So for example, now on this terminal now is a Linux machine. You are going to trying to reach home, Rome, right? And the person is what? York. So just do traceroute Rome. Okay, so this is Rome here. So it takes what? Through what? London, right? So London is the first hop. Goes through what? Paris, which is the second hop before it gets what? Rome. So you can see the time that it takes. So next we're going to actually build a simple network and we'll do some of the practicals. And I guess I'm going to unlock the labs on the Cisco NetAcad forum. I've already unlocked the exam, so everybody can take the exam. After watching this recording, you can just go and attempt the exam, then attempt the labs that are associated with this. Attempt the lab from online so that it's connected to your NetAccount uh, platform. And when you're done, your score is going to reflect on your platform. So we'll call it, that's where we're going to end for today. Until
Okay, that's fine.